In this example, we'll test a claim about the population mean when the population standard deviation is unknown. An insurance company is reviewing its current policy rates. When the rates were originally set, the company believed that the average insurance claim amount was $1,800. Now they're concerned that the true mean is actually higher than $1,800, which would lead to a loss of profits if the rates are not adjusted. A simple random sample of 40 claims was selected. The sample mean was $1,950 and the standard deviation was $500. Use a significance level of 0.05 to test the claim that the mean insurance claim amount is more than $1,800. Okay, let's note some of the information we've been given. We are to use an alpha of 0.05 to test our claim. We've been given the sample mean of $1,950, a sample standard deviation of $500, and our sample size was 40. Let's see, now we'll note the original claim. The original claim was the mean insurance claim amount is more than $1,800. So the competing claim the mean is less than or equal to $1,800. Okay, null hypothesis. The mean is $1,800. The alternate hypothesis then, well, the condition of equality is with the competing claim, so the original claim corresponds to our alternate hypothesis. Mu is greater than $1,800. Okay, so we will compute a critical value, get a test statistic, a p-value, and use that information plus our decision diagram to make a decision. Okay, let's start the diagram. Has that bell shape, just like the normal distribution. Okay, but we'll be using the t. The mean is still 0. And we have a right-tailed test. The inequality is pointing to the right. Our alpha is 0.05. We'll find our critical value using inverse t, the program on the calculator, or you may use the tables in the back of your book. We enter area to the left. The area to the right is 0.05, so area to the left is 0.95, comma, and then we enter our degrees of freedom. We'll recall that degrees of freedom is 1 minus the sample size, so I'll come back up here. Degrees of freedom is going to be 40, this is sample size minus 1, sorry, 40 minus 1, n minus 1, so 39. Okay, so using this function on the calculator or looking that up in the on your table in the textbook, you'll get 1.68. We were looking for a positive critical value. It makes sense that we got 1.68. So here I'll indicate 1.68, and here I'll state that my t value is 1.68. Okay, now we're ready to run our test. to get the test statistic and the p-value. So test, stat, tests, and now we're using the t-test. We tab down to t-test for the student t-test. We still have the choice of data or stats. I do not have the data, but I do have stats. My mu sub 0 is 1800. My sample mean was 1950. Sample standard deviation was $500. The sample size was 40. And this is a right-tailed test. Then we calculate. So our t-test statistic is 1.897. Rounded to 2, that'd be 1.90. And our p-value is 0.0326. Okay, so our test statistic 1.90, p-value 0.0326. Alright, where would 1.9 be? Somewhere here. So we can see the p-value going out the tail right here. And based on our traditional method, the test statistic does fall in the critical region, which tells us to reject the null hypothesis. Also, our p-value 0.0326 is less than alpha 0.05. So they agree as they should, and we reject the null hypothesis. Okay, now we're ready to write our conclusion. Does the original claim contain the condition of equality? No, it does not. Did we reject the null hypothesis? Yes, we did. So our conclusion begins, the sample data support the claim. That the mean insurance claim amount is more than $1,800. Okay. So recall, since the original claim does not correspond to our null hypothesis, rejecting the null hypothesis gives us evidence to support the claim. And so the insurance company would probably want to look at possibly adjusting their rates.